In this section, we cover a lot of fundamentals that are essential to your success in algebra. So we're going to go over these concepts again to give you a bit more practice. So the first concept we'll talk about is translating English sentences into mathematical expressions. Now when you work with math, you deal a lot with symbols that represent quantities. And sometimes those symbols can seem like a foreign language. So we're going to practice a bit more and that'll help with your fluency. So the first sentence we'll translate is the difference of 6 and x is y. Now these words in this sentence all represent mathematical symbols. So we can look at the first one, the difference. Difference represents subtraction, so we know that we're going to have a minus sign in our expression. And we're finding the difference of this quantity, 6 and x. So we write that as 6 minus x. Now in this sentence, the word is represents our equal sign. So we'll write that next, and then bring down our final variable y. So the difference of 6 and x is y, translates to 6 minus x equals y. Let's move on to our second sentence. It's a little more complicated and has a few more components to it. So we have half the difference of t and s is less than twice the sum of t and s. Looking at this first word, half, we're going to translate that into a fraction and write 1 over 2. Now this fraction here is we're taking half of this quantity, the difference of t and s. So that means that we're going to put some parentheses into our expression. And inside our parentheses, we're going to write the difference of t and s. Now difference again represents subtraction, so we're going to subtract t and s. So t minus s is our expression inside these parentheses. Now moving on, this phrase is less than. This translates to our less than symbol, and then twice we can represent by the number 2 because we're going to double the sum of t and s. Now again, this is a quantity, so we're going to use some parentheses again, and inside our parentheses, sum represents addition, so we're going to add a plus sign, and we're adding t and s, so t plus s goes inside our parentheses. So this sentence, half the difference of t and s is less than twice the sum of t and s, translates to 1/2 times t minus s is less than 2 times t plus s. So let's move on and we'll work with simplifying and using our order of operations. Now the order of operations is a very important strategy to use when working through math problems. I'm going to walk you through a few problems and you'll see that although they have some similar numbers, the order and the grouping of their operation symbols is different, therefore they're going to have different answers. So let's review these steps to the order of operations first. Our first step is to work through all the math inside a set of parentheses. The second step is to work with the exponents. The third is to work the multiplication and the division present in the problem. And the fourth step is to work the addition and the subtraction. Now another important thing to remember when using the order of operations is that you move from the left side of the problem to the right side of the problem as you do your math within any of those steps. So first let's try this problem here. We have 2 plus 3 times 2 squared plus 3 squared. Now working with our order of operations, we're looking for parentheses first. Now in this problem there are none, so we're going to move on to our second step, which is working our exponents. So we have 2 plus 3 times 2 squared is 4 plus 3 squared is 9. Now we can move on to our third step in the order of operations, which is working the multiplication and the division. So we're going to bring down our 2, we're not going to work with that just yet, and we're going to find the product of 3 and 4, which is 12, and then bring down our 9. Now we can move on to our final step of the order of operations and work our addition. Again, we're going to move from the left side of the problem to the right side of the problem, so we're going to add 2 plus 12 is 14, then 14 plus 9, which is 23. So 23 is our answer when we simplify our first problem. The second problem here, we have 2 plus 3 times the quantity 2 squared plus 3 squared. So we're going to look inside our parentheses first and work this math. So we have 2 plus 3, we're not going to work with that just yet, inside our parentheses. Then we can use our order of operations within these parentheses, and we're going to work our exponents before we find the sum. So we find 2 squared, which is 4, plus 3 squared, which is 9. Now we're still working inside our parentheses to simplify this as much as we can. So we have 2 plus 3 times the sum 4 plus 9. So we're going to add these, which is 13. Now we can move on. We've simplified everything within our parentheses, so we'll move on down the list and work our multiplication. So we have 2 plus 3 times 13, which is 39. And now we can do our final step of addition. 2 plus 39 is 41. So there's our answer for our second problem. Let's do our last one. Here we have the quantity 2 plus 3, and that sum we are multiplying by 2 squared plus 3 squared. So we're going to work inside our parentheses first, moving left to right, so we're going to work our first set of parentheses first. 2 plus 3 gives 5. Now in our second set of parentheses, we're going to move down the list and do our exponents first again before we do our sum. So 2 squared is 4, plus 3 squared is 9. And now we can simplify within this set of parentheses here. So we have 5 times 4 plus 9 is 13. And now we can do our multiplication. So 5 times 13 is 65. So there you go. Now we'll move on and we'll talk about some properties that will help you simplify some expressions. When simplifying expressions, it's important to become comfortable with 3 main properties. The first of which is the commutative property, and this works for addition and multiplication. So for addition, this property states that you can change the order of any 2 numbers in a sum and not change the result. So we have A plus B is the same as B plus A. Now for multiplication, the same thing goes. You can change the order of 2 numbers in a product and not change the result as well. So we have A times B is equal to B times A. Now our second property here is called the associative property, and this says that you can change the grouping within a sum and not change the result. So we have A plus the sum B plus C is equal to the sum A plus B plus C. And then the associative property for multiplication says that you can change the grouping within a product and not change the result as well. So we have A times the product BC, that is equal to the product AB times C. Now our third property is called the distributive property, and this states that multiplication distributes over addition. So if we have a number outside a sum here, our number is A, this will distribute over each term within this sum. So this A times the sum B plus C becomes AB plus AC. So let's work through a couple problems here and see how these properties apply. For our first problem, we have 3 plus 4 times the quantity 5A plus 3 plus 4A. So we're going to use our order of operations as well as these properties to simplify this expression. So first off, let's look inside our parentheses. Now these 2 terms are not similar, so we can't simplify that any further, and we don't have any exponents to work, so let's move on to multiplication. Now this is where our distributive property comes in. So we are going to distribute our 4 over each term inside these parentheses. So let's bring down our 3 because we're not going to work with that just yet. We're going to distribute our 4 over the 5A and the 3. So 4 times 5A is 20A, and then 4 times 3 is 12. So we're going to add 12, and then bring down our final term, which is 4A. So now we're going to use our commutative property for addition to rearrange some of these terms and make them easier to work with. So as we can see, we have 2 whole numbers and 2 terms that include a variable. So let's move our terms that have a variable over here. We have 20A, and then let's bring 4A over here as well. And then we'll bring our 3 and our 12 over. So now since we've rearranged these terms, we can apply the associative property and group them in order to simplify. So let's group our terms that have our similar variable and group our whole numbers. And then we'll add. So we have 20A plus 4A is 24A. and then 3 plus 12 is 15. So our final answer, simplifying this expression, gives 24a plus 15. Let's try another one. So here we have 4 times the difference, 2 minus 6x, minus the difference, 3 minus 4x. So the first thing that I'm going to do here is I'm going to change all my subtraction signs into additions plus a negative. So here we're going to add negative 6x. This subtraction sign here is as if we were adding a negative 1 times this quantity. And then this subtraction is adding negative 4x. That'll make the math a little bit easier to work with. So now let's first start. We're going to work from left to right here, and let's use our distributive property to distribute this 4 over each term inside these first parentheses. So we have 4 times 2, which is 8, and then we're going to add 4 times negative 6x, which is plus negative 24x. And now looking over here to our second set of parentheses, we have a negative 1 here that's going to distribute over each term. So we're going to add negative 1 times 3, which is negative 3, and then negative 1 times negative 4x, which gives us positive 4x. Now, just as we did in our first problem, let's rearrange some of these terms to make the math easier to work with and combine, then simplify. So we'll move our negative 24x first, and let's bring our 4x over right next to it. And then we'll group our whole numbers here, 8, and our negative 3. So now let's group these using our associative property. So we're going to add this sum and this sum. So negative 24x plus 4x gives us negative 20x. And then we're going to add 8 plus negative 3, which is 5. So this is our final answer for our second problem, negative 20x plus 5. So it's also so important to note that you could rearrange these terms according to our commutative property for addition and still have the correct answer. So we could write 5 minus 20x, and these two expressions are equal. So let's move on to our final concept, and we're going to talk about sets. When working with a set, you're working with a collection of things, and in our case, those things are numbers or variables. Those numbers or variables, they are called elements, and we can write the elements of a set within a set of brackets. We can also write an element of a set using this notation. Now this symbol here represents that x is an element of set A. So this is important notation that you should remember when you're working with sets. The other symbol that we'll use if we deal with a set that doesn't have any elements to it, we call it an empty or a null set, and we use this symbol. So this symbol here represents an empty set, which is also called a null set. And that means that it's a set that doesn't have any elements in it. Now we'll use two basic operations when dealing with sets, the first of which is a union. The union means that for set A and set B, we're finding all of the elements that are contained in either one or the other. So the word or here is an important one to remember. We can write the union of set A and set B using this symbol here. So this means that all of the elements in set A or all of the elements in set B are what we're considering. So this is the union of set A and set B. Our second operation is the intersection of two sets. And the operative word here is and. So when we talk about the intersection of two sets, we're looking at the elements that are contained in one set and in the other set. So they're in both. And we use this symbol to denote an intersection. So this is the intersection between set A and set B. Now the final notation that we'll discuss here is called set builder notation, and this is a way to kind of summarize all of the elements that you're considering when you deal with two sets. So let's use the union of set A and B as an example. So we'll write that like this, and we can write the union of set A and B is equal to all of the values for x such that, this vertical line here represents such that, x is an element of A, here's this notation here, or, because we're dealing with a union, we're going to use the word or, x is an element of set B. So there's your set builder notation. Let's try an example. So let's consider set A includes the elements 0, 2, 4, and 6. Set B includes the elements 1, 2, 3, 4, and 5. And set C includes 1, 3, 5, and 7. What if we needed to find the elements in the union of set A and the intersection of B and C? Now we can use our order of operations and work inside our parentheses first. So let's find the elements that are contained in the intersection of set B and C. So here, if we're dealing with the intersection, we're looking for all of the elements that are contained in both sets. So looking up here for set B and then comparing it to set C, we have 1 in both sets, 2 is not, but 3 is in both sets, 4 is not, 5 is in both sets, and 7 is not. So this set is 1, 3, and 5. Now let's bring down and compare this found set that we just did to the numbers that are the elements in set A. And we need to find the union of set A and these elements here. So when we deal with union, we're dealing with the numbers that are in either set A or the second set. So if we look at set A, we have the numbers 0, 2, 4, and 6. Okay, so our elements for this notation here are 0, 2, 4, and 6, or 1, 3, and 5. So we can combine these and write 0, 1, 2, 3, 4, and 5. So these are all of your elements that are in the union of A and the intersection of B and C.